This section is on apportionment methods. Apportionment deals with having a limited resource and how do we distribute or how do we apportion that resource across different groups. So we will be dealing with questions where we have a certain number of medical clinics and we only have a limited number of doctors. So how do we apportion or how do we distribute those doctors across those different medical clinics? We will be dealing with questions with states and Congress seats. So we have so many states, we have only so many Congress seats, and how do we distribute those Congress seats amongst those states? So there's really many different applications, and the reason why we have so many different apportionment methods is because most of the time things don't divide out evenly. So what do we do with the decimal? So all of this has to deal with how do we deal with the decimal. Number 1 says an HMO has 10 doctors to be apportioned among 3 clinics. The HMO decides to apportion the doctors based on the average weekly patient load for each clinic. Complete the following apportionment table. So we have 3 clinics and they have listed the average weekly patient load. So that's also here in this column. And the first thing I need to do is add these up. So 119 plus 165 plus 216 is 500. Now I'm ready to find the standard divisor. So to do this, we need to divide the total population by the number of people to apportion. So we have 500 total, and we need to divide this by the number of doctors that we are trying to apportion, which is 10. So 500 divided by 10 is 50, which is our standard divisor. Next, we want to find the standard quota. To do this, we need to divide the group's population by the standard divisor. So 119 divided by 50 is 2.38. 165 divided by 50 is 3.3. And 216 divided by 50 is 4.32. And if you add all of these up, you get 10. So this should equal 10 because we have 10 total doctors that we are trying to apportion. So in a perfect world, you would give each of these clinics exactly these many doctors. But the decimal doesn't make any sense, so this is where the other methods come in. The first method is Hamilton's method, but before we can complete Hamilton's method, we need to know the lower and upper quota. So to find the lower quota, we need to round down the standard quota. So I want to look at the numbers in the standard quota column and round them down. So 2.38 rounds down to 2, 3.3 rounds down to 3, and 4.32 rounds down to 4. And if I add these up, then I get 9. Again, we have 10 total doctors, so I do want to make a note for later that we do need one more. Next is the upper quota, which says we need to round up the standard quota. So I want to look at the numbers in the standard quota column and round them up. So 2.38 rounds up to 3, 3.3 rounds up to 4, and 4.32 rounds up to 5. So if I add these up, I get 12. Now that's more than the 10 doctors that we have, but that's okay for this column. Now we can complete Hamilton's method. So for Hamilton's method, we need to initially give each group its lower quota. Then we need to give surplus items one at a time to the groups with the largest decimal parts in their standard quotas until there are no more surplus items. So I want to initially give each group its lower quota. So Clinic A is going to get 2, Clinic B is going to get 3, and Clinic C is going to get 4. Then I want to give surplus items one at a time to the groups with the largest decimal parts in their standard quotas. So we have one surplus item because these add up to be 9 and we have 10 total doctors. So I need to find the clinic with the largest decimal part in their standard quota. So that means I'm looking at the 0.38, the 0.3, and the 0.32. And of those three decimals, which is the largest decimal? And that would be 0.38. So that means I'm going to give the last doctor to Clinic A. So this changes from 2 to 3. And now if I add these up, this equals the 10 total doctors. So we are apportioning 3 doctors to Clinic A, 3 doctors to Clinic B, and 4 doctors to Clinic C. Next we are looking at Jefferson's method. And for Jefferson's method, we do not need to know 1 through 5. So we don't care about the standard divisor, we don't care about the standard lower and upper quota, and we don't care about Hamilton's method. So we are basically starting over. So we want to divide the group's population by the modified divisor D and then round down. So I'm going to take the population 119 and divide it by the modified divisor 43 and then round down. So 119 divided by 43 is 2.76. So rounding that down to the nearest whole number would be 2. Then I'm going to take 165 divided by 43 and then round down. So 165 divided by 43 is 3.83. So rounding that down is 3. And then lastly, 216 divided by 43 is 5.02. So rounding that down is 5. So these add up to be 10. So A gets 2, B gets 3, and C gets 5. And as you can see, that is different from what we found with Hamilton's method. Next up is Adams' method. And just like Jefferson's method, we are starting over. So we want to divide the group's population by the modified divisor D and then round up. So if we take 119 and divide it by 55.4, we get 2.14. So rounding that up rounds to 3. If we take 165 divided by 55.4, we get 2.97. So rounding that up gets us 3. And then lastly, if we take 216 divided by 55.4, we get 3.89. So rounding that up gets us 4. And if we add these up, we get 10. So by Adams' method, we give Clinic A 3 doctors, Clinic B 3 doctors, and Clinic C 4 doctors. The last method is Webster's method. And just like Jefferson's and Adams' method, we are starting over. And this says we need to divide the group's population by the modified divisor and then follow traditional rounding rules. So if we have a 5 or greater in the tens place, then we need to round up that number. So I want to take 119 and divide it by 47.7. And I get 2.49. So this is going to round down to 2. 165 divided by 47.7 is 3.45. So that's going to round down to 3. And then 216 divided by 47.7 is 4.52. So that's going to round up to 5. And these add up to be 10. So by Webster's method, Clinic A gets 2 doctors, Clinic B gets 3 doctors, and Clinic C gets 5 doctors.